stop, wait. I'm going to do a construction of an isosceles triangle in Geometry Sketchpad. So to start to construct an isosceles triangle, I am first going to construct a segment. So I will select the segment, start a point, and create that segment. I'm then going to highlight an endpoint of the segment. Once I hit the arrow selection tool, so that I have my segment and my endpoint highlighted, and I will go to the construct menu and I will construct a circle by the center and radius. I'm going to move my circle a little bit so it's in the screen where I can see it. Then I will select off of that, and I'm going to choose the circle, and I'm going to pick construct a point on the circle. Once I have the point on the circle, I'm going to go and highlight another endpoint, and this endpoint will be the center of the circle. And between the point on the circle and the center that I have highlighted, I go back to construct, and I will construct the second segment. Then I need to make sure that I unhighlight the segment. That seems to be the thing that I forget all the time. While I'm doing this, I'm going to go ahead and select my marker, and I want to mark my two segments so that I can mark them congruent. I'm going to go back and pick my arrow and select off that mark that I just made. I'm going to highlight the two endpoints on the circumference of the circle, and I'm going to construct my third side of my triangle, which I now have my isosceles triangle, but because I don't want to see my circle, I will go back and highlight the circle, and I will go to display, and I will hide my circle. I now have constructed an isosceles triangle. We know it's isosceles from the definition because I have the two radii of the circle, and they are clearly congruent. And it's nice because as I drag my circle around, I can tell that my two radii stay fixed, where they adjust to each other. I did not use any of the underlying subproperties of a isosceles triangle in this particular construction, but there are lots of properties that could be discovered, or by using the measure buttons, we could confirm that indeed the base angles are congruent, that a perpendicular bisector would intersect the base of the triangle at the midpoint and create two congruent segments, and that would also bisect that top vertex angle and create two small angles and two congruent triangles.